Now, you know that, okay, we have the analysis tool, so-called Phasor. Okay, the Phasor can convert the sinusoidal waveform into about simple linear complex number form. Okay, and you can use the Phasor to analyze the circuit. Okay, in that manner, you know that. Okay, you convert the sort to be the Phasor form. You convert the resistance, inductance, and the capacitance into impedance form, and you can apply the Ohm's law. Okay, Ohm's law, Kirchhoff law, and Kirchhoff voltage law, Kirchhoff current law. Okay, you can use, okay, the current divider or the voltage divider techniques. Okay, now everything that you treat, okay, that you compute in the Phasor domain will be the same as the DC circuit analysis, but a little bit different. Every number instead is real number. No, it is complex number. We will extend the idea to more complicated analysis systems, such as the nodal analysis and the met analysis, okay, in this section. Then, okay, the nodal and the met analysis, for this, we have the Ohm's law for the Phasors for the passive element. V equal to IR or I set in this case. The Ohm's law upon which the nodal analysis rests true for the Phasor, and we may proceed to analyze the circuit by the nodal technique in the sinusoidal steady state. Using a similar argument, we can establish that met analysis methods are varied and often useful as well. The way to apply and the step to apply nodal analysis and the met analysis is the same. Everything is the same as the DC circuit analysis. But in order to give you more understand, I will provide you the real example case. Okay. Now in this circuit, okay, if we convert the sort to be the Phasor form already, okay, and if we convert the resistance, capacitance, and the inductance into impedance form, everything already convert clearly. Now, the key, okay, the highlight of this section of the example is how to apply the nodal analysis to determine, okay, V1 and the V2 in this idea. Okay. Wait a minute.
Did you see her, bro?
Okay, due to your friend is off the, okay, the microphone. Okay, I will turn off it. Okay, now, okay, in this circuit, okay, we have three nodes. Okay, node 1, node 2, and the node 3. Okay, the node 3 is already the ground because, okay, you know that, okay, this case, in this case, the question is already forced them. Okay, it's already the ground. Okay, we change, okay, the ground to be reference nodes. Okay, 1 to be the node 1 is a V1, node 2 is a V2. Okay, now, okay, you can apply, okay, and all sort, you can see that, okay, sort, all sort in the circuit, so it's only the current sort. Therefore, you can apply the nodal analysis to analyze them. In the node 1, at the node 1, okay, we have how many branch connect to them? 1, 2, 3, 4, and 5. 5 branch connect between nodes 1 and the other node, okay. How many current get in? 1. It's only 1 0 degree, okay. 1 current get in. We can apply the Kirchhoff current law at this node. Only 1 current get in, 1 0 degree. The rest is the resistance or the impedance in this case. We assume them to get out. Now, and here, V1 minus 0 divided by 5. V1 minus 0 divided by 5. Okay. Here, this node, V1 minus 0 divided by minus 10J. V1 minus 0 divided by minus 10J. Yeah, this branch, okay, V1 minus V2 divided by minus J5. V1 minus V2 divided by minus J5. And the last one is here, V1 minus V2 divided by J10. V1 minus V2 divided by J10, okay? You can see that everything that you treat is the same as the normal nodal analysis, except it's a complex number. Okay, you reorganize the equation to be, okay, a V1 with its coefficient, V2 with its coefficient equal to constant. Okay, Next one, we apply the KCL to node 2. The KCL to the node 2, we have 5 band connect to them. 1, 2, 3, 4, and 5. But in this case, any current get in? No. 0 current. 5 current out. 5 current is get out. For here, 0.5 minus 90 degree. 0.5 minus 90 degree. Okay. Here, V2 minus V1 divided by minus J5. V2 minus V1 divided by minus J5. Here, V2 minus V1 divided by J10. V2 minus V1 divided by J10. Okay. Here, V2 minus 0 divided by J5. V2 minus 0 divided by J5. V2 minus 0 divided by 10. Okay, yeah. You get two equations, okay? Two equations, two unknown, okay? You can solve it, okay? You can formulate them into this metric form. This equation can be written in the metric form as here, okay? The coefficient of them, yeah? V1, V2, V1, V2 is here. Okay, the coefficient of them, 0.2 and minus and plus 0.2j is here. Minus 0.5, minus 0.1, minus 0.1j is here. And the second equation equal to 1, equal to 1. Okay, and the second equation will be line here. Now, by this, okay, you can determine V1 by, you can see that in this case, you cannot use a simple substitution technique like if the coefficient of them and if the value of V1 and V2 is a real number, yes, you can use the substitution technique or you can push them into your calculator. But now you cannot. If you cannot determine V1 in that manner, how to determine them? You can use the comma rule and determinant that I already teach you in the nodal analysis section, or you can go back to read the detail in that book. Okay, okay. It have the numerator and denominator. The denominator equal to the whole term, the zero term in here, and the determinant of them. How to determine the determinant? Okay, you can find from the calculus. Okay, in the calculus, and here is the same. It's the same value, but the first row replaced by this constant. Okay, the first row to represent about the value, the solution of V1. Okay, and for V2 is the same. Okay, the ratio between the numerator and numerator is here. The denominator is the same. For the numerator in this case, you substitute 1 and 0.5j to be the second row instead, to the second row. Okay, next one, you can determine the solution in this case. This equation are easily solved on the most scientific calculators or maybe by hand, and the resulting is V1 equal to 1 minus 2j volt, V2 equal to minus 2 plus 4j. Okay. In this case, if you would like to determine the time domain solution, you can obtain by express V1 and V2 in the polar form first. Okay, convert V1 into the polar form, give you 2.2 at the minus 63 degree. Okay, and you can convert the polar form will be in the sinusoidal 2.4. Okay, cos omega t minus with the 63.4 degree. In this case, you don't know about the omega, therefore we push the omega as the unknown. Okay. The next one, V2 equal to minus 2 plus 4j, you can determine the polar form is equal to 4.5 at the 116 degree, okay, or equal to 4.5 cos omega t plus 116 degree, approximately that. Okay. Now, the value of the omega would be, okay, have to be known in order to compute the impedance value given on the circuit diagram. Both sources must be operated at the same frequencies. Okay, you can see that in this case, in the circuit, we have two sources, right? Two current sources. One is 0 degree, another is 0.5 at the minus 90 degree. Both sources must be operated at the same frequency that you can apply this nodal analysis to determine V1 and V2 like here. Now, the next one, determine the time domain's current. Okay, I1 and the I2 in the circuit shown in this figure. Okay, in this case, okay, the circuit is comprised okay, you can check the sort first. All sort in the circuit is a voltage sort. Therefore, you can apply the meta-analysis to them. Before you apply the meta-analysis, you must convert. But the sort, okay, the sort is still 10 cos, okay, 1000 t. Is not the phasor form, okay. And the impedance, the resistance, and the inductance and the capacitance value is not present in the impedance value yet. Therefore, you must convert them first, okay. We convert the sort, okay. 10 cos 1000 t is already equal to 10 0 degree, okay. In this step, you know omega equal to 1000, okay. Omega equal to 1000. Therefore, okay, you can convert, okay, the inductance, capacitance, and the resistance to be the phasor form, okay. Give you here from 4 millihenry to be 4J, okay. 3 ohm equal to 3 ohm, okay, and 500 microfarad equal to minus J2 ohm, okay. After, so anything?
อันนี้ผมไม่เข้าคลาสนะครับคือผมอยู่โรงพยาบาลครับ
อ๋อไม่เป็นไรเป็นไรหรือเปล่า
ผมบาดเจ็บแต่หลังล่างครับ
นะ
ผมบาดเจ็บหลังล่างครับ
อ๋อเหรอไปโดนอะไรมาไม่เป็นไรรีบไปรักษาตัวเองก่อนแล้วค่อยมาคุยกับอาจารย์ก็ได้นะไปรีบไปพักผ่อนไปรักษาตัวเองก่อนไม่เป็นไร
ผมต้องใบรับรองแพทย์ไปให้อาจารย์ให้แสดงอาจารย์ไหมครับ
ไม่เป็นไรผมเป็นเคสbyเคสแค่บางคนผมพอจำได้ไม่เป็นไรก็ก็ดาวน์โหลดสไลด์เดี๋ยวจะแป๊บนึงนะเดี๋ยวเช็คนิดนึงรู้สึกก็ใน Microsoft Teams มันเรคคอร์ดอยู่นะมันอัดไว้อยู่คุณดูย้อนหลังได้นะครับ
โอเคครับ
ถ้าไม่มีจริงส่วนใหญ่ผมก็จะดาวน์โหลดเก็บไว้ให้นะแต่ว่าก็ต้องผมก็ไม่รู้กันจะวิธีส่งให้พวกคุณยังไงนะแต่ว่าก็เดี๋ยวไปดาวน์โหลดเอาหรือว่าคุณพอเสร็จปั๊บคุณจบคลาสปั๊บคุณเข้า Microsoft Teams แล้วโหลดเก็บไว้ก็ได้นะจะได้ตามเพื่อนให้ทันโอเคนะครับ
ได้ครับ
โอเคนะไปพักผ่อนก่อนไปรักษาตัวที่โรงพยาบาลให้เรียบร้อยก่อนนะไปไม่ต้อง
ครับ
โอเค Okay, sorry for a little bit one, okay, due to your friend. Some of your friend is already in the hospital, okay? Is okay. We go back to the lecture again. Okay, anyone? Everyone can, right?
อาจารย์500ไมโครฟาราดมันเปลี่ยนเป็น2มันเปลี่ยนเป็น J2 ได้ไงครับอาจารย์
1ส่วน J โอเมก้า C ไงครับ
อ๋อโอเคครับ
Okay. You can convert, okay, 500 microfarad to be, okay, minus J2 by using, okay, the ZC equal to 1 divided by 1 equal 1 divided by J omega C. Okay, ZL equal to J omega L. Okay, ZR equal to R only. Okay, now, after you get here, you can define the mesh current I1 and the I2 in here, and you can establish the mesh current to them. Okay, you apply KVL. You apply KVL. We apply the KVL to these two. Yeah, to this loop, we apply in this loop, right? In this mesh. Okay, here V minus first is minus 10 0 degree, minus 10 0 degree. Yeah, here 3 I1. 3I1 is here. Okay, for this is equal to 4J I1 minus I2. 4J I1 minus I2. Okay. Reorganize the equation to be here. I1 with a constant coefficient, maybe complex, we don't care. Okay. I2 with a constant coefficient and equal to the constant. Now for the mesh 2, here, plus first, right? Therefore, equal to 2I1 plus 2I1. Okay, plus 2I1. Okay, for this, okay, plus 4J I2 minus I1, plus 4J I2 minus I1. And here, minus J2 I2, minus J2 I2. Reorganize the equation again, give you here. Now you have two equations, two unknown, okay? Two equations, two unknown. You can solve them, okay, by the Karma rule and determinant and so on. We will give you here I1 equal to 1.0x plus 0.6j or equal to 1.24 at the about the 30 degree. Okay, I2 equal to 1.5 plus 2.3 J, or equal to the 2.8 at the 56 degree. Sorry. Yeah, or you can convert them into the time domain form. Into the time domain, you know omega in this step equal to 1000. Okay, you know from the sort that give it to you, right? Omega equal to 1000. Okay, in here. Okay, you can convert them back from the Phasor 1.4 cos 1000 kt plus with 30 degree, approximately that. And here is equal to 2.x cos 1003 plus with the 64 or 56 degree. Okay. Okay. The next one, you can apply the other techniques such as the superposition, the sort transform, and the Thevenin equivalent circuit, Norton equivalent circuit to this Phasor circuit. The same, every technique that you have studied in the DC circuit analysis, you can apply in the Phasors, okay? But you treat them in the complex number form, okay? After the inductor and the capacitor were introduced in the chapter 7, we found that the circuit containing these elements were linear. For the linear property, this circuit or the Phasors form, which are applied by the sinusoidal sort, can be analyzed by the principle of superposition, the Thevenin and the Norton's theorem, and the sort transform. Now, in order to demonstrate your idea, okay, we will apply the superposition to you, okay, the circuit that present in the previous example. But if I order you to determine them by the superposition, we would like to determine V1 from the superposition point of view. It means you activate one sort and you kill another sort. In this case, you have two independent sorts. You take them or you compute them two steps. The first one, okay, the first one is here. Before we analyze them in this case, you can simplify the circuit first, okay? The two impedance, phi and minus 10J, is connected in the parallel. You can combine them in the parallel manner, okay? And here, the next one is here. Another two will be combine them between 5J and 10 ohms, okay, in the parallel form. And here is already, okay, the capacitance ZC and the ZL will be combined them in the parallel form again. Now the circuit can be simplified in this manner. The key, you would like to find V1, okay, from each sort. Therefore, in the first step, you may be activate, okay, the first sort, okay, the sort in the left hand. The sort in the right hand, you deactivate them. How to kill the current sort? You kill by open circuit it, and the branch is become broken, okay. It have no current flow in here. It have no effect from the right hand side sort. Only the left hand sort will be flow in here. In this case, the current flow in here split in two. You can find the current in each, and you can find the voltage across them. Okay, two of them. After you can see that after you kill the sort in the right hand, two impedance is connect in the series. You can combine them by adding them to, okay, minus 6 ohm. Okay, now after you get here, you can find, you know, the total current flow in here split in two. Okay, you can combine them, right? In fact, sorry, you can combine them first. Okay, in order to determine V1, combine them as the parallel. The current flow in here, V equal to IR. V equal to IR. You know R, you know I, you can find V. Very easy one. The second one is a little bit more complicated when you kill one 0 degree sort. When you kill one 0 degree sort, the branch is broken and the current flow in here split into. In this case, you cannot combine them. Even though this impedance and this impedance is connected in the series, you cannot combine, because if you combine them, V1R is gone. If V1R is gone, you cannot find the voltage at the V1R anymore. You cannot combine them. Therefore, the current may be flow in here split in two. You must find the current that's flow in only 4 minus J2 first, okay? Now you can use the current dividers, okay? The total impedance in the left-hand branch equal to 4 minus J2 and minus J10, yeah? And the current flow in the right-hand, the right-hand side branch equal to 2 plus 4J. One current flow in here split in two. The current that flow in this branch equal to the total current flow. Okay, minus, sorry, 0.5 at the minus 90 degree here. Okay, multiply with the resistance in another branch. Another branch is here. Okay, 2 plus 4J, and the sum of the resistance in all. Okay, is okay. 4 minus J2 is here. Combined with the minus J10 is here. Plus with okay 2 plus J4. You can find the current.
What happened?
His internet gone.
Johnny's gone.
Internet.
Oh, sorry. Hello? Anyone can hear me?
Yes, Ajahn.
Yes.
Yes, Ajahn.
Okay. My internet will be interrupted a little bit, maybe refresh a little bit one, okay? Yeah. Okay, wait a minute. Okay. Can you see my slide?
Yes. Sir.
Yes.
Okay, new from the previous one, okay? Okay. Okay, in this step, you can see that when you use the sort in the left hand, okay, you activate only sort in the right hand. The sort in the right hand is the current sort flow in here, split in 2 parts, right? Split into one, it flow in 2 plus 4J. Another one flow in here. From the current dividers technique, we will state that, okay, the total current flow in this resist, okay, flow in the impedance bar, equal to the total current 0.5 at the minus 90 degree, 0.5 at the minus 90 degree, okay? Okay, multiply with the impedance in another branch. The impedance or the resistance in another branch is 2 plus 4J, right? 2 plus 4J. And the sum of all. Okay, the sum of all. The sum in the left hand is 4 minus 2J minus 10J is here. And 2 plus 4J is here. Okay. After that, you get I. The key is here. Be careful. Okay. I think the way to multiply them, you change them to be the Phasor form, okay, to perform the complex form, convert them, and so on. I don't care. Okay, I think you can find it. Now, the current will be get up. You can see that the current will be get up. Okay, but the voltage that you assume will be VIR will be in this. Therefore, VIR is V equal to I is I1R. Okay, and multiply with this impedance, right? But the direction of the current is reverse, right? Therefore, you must take minus in here, because the current must be flow from the some voltage level to ground, okay, to here, okay. But the current here will be flow reverse direction, okay. You get one VIR equal to IR1 is here that you compute from the previous step, okay. Multiply with the impedance, V equal to IR. V1R equal to minus 1. Okay, minus 1 volt. Now the total voltage is equal to the voltage from the left hand add with the voltage from the right hand. You adding them, give you here. Okay, see? Okay, the next one is discuss about the Phasor diagram. The Phasor diagram is a name given to a sketch in the complex plane, showing the relationship of the Phasor voltage and the Phasor current throughout a specific circuit. To provide the graphical method for solving certain problems which may be used to check more exactly analytics method to display the complex power relationship in the sinusoidal steady state in the chapter 11. Okay, the key for the Phasor, you maybe see them considerably weird, is maybe see them at abnormal plotting, because we plot the current and the voltage in the same diagram, even though it's different unit. You can see that because 5 volt cannot compare with the 10 amp, cannot. Yes, the key, you may have the question, and why we plot them? We would like to find the angle between the current and the voltage, and only way to provide that picture point of view in the graphical point of view is to plot them in the Phasor plane or the Phasor diagram. The Phasor diagram is very powerful tool for analyze the current and the power and the voltage in the AC circuit analysis. Okay. Now we are familiar with the use of the complex plane in the graphical identification of the complex number and for addition and the subtraction. Now, before we go to the Phasor plotting, okay, I will show you in the simple Phasor plotting first. Okay. For example, if V1 equal to 6 plus xj, 6 plus xj, okay, the complex plane, the horizontal axis is a real number. The vertical is imaginary number. Okay. Now, you plot them 6 plus xj, the real is 6, okay, x is imaginary, 6 plus jx is here. Okay, equal to 10 at the 53 degree. 10 at the 53 degree is identified on the S plane in here. When you plot them, you use the vectors. The head of them have the arrow. Okay, every vector have the start from the origin. Okay, the magnitudes of them, okay, or the range of this vector equal to, okay, real part square with the imaginary part square, and you take square root. In this case, it's equal to 10. And the phase angle in the polar form, the phase angle is 55 degree or 53 degree. 53 degree is the phase, okay, is the angle between the vector and the real axis. Is here. Okay, now you know how to plot them roughly. The next step, how to manipulate, how to adding them or how to manipulate them roughly. Okay, the first one, if we have two vectors, the first one is V1 equal to 6 plus xj, V2 equal to 3 minus 4j. If you adding them, yes, you can adding them by number. Okay, real part and the real part, imaginary part and imaginary part. Real part equal to 3 add with 6 equal to 9. Okay, plus xj and minus 4j, it give you plus 4j at the result. But when you plot them, two vectors, you can plot them in this manner, right? In the diminished manner, okay? V3 equal to here. Okay, the way to plot them in the Phasor is, okay, is in the graphical point of view, it can provide you recheck your answer. Okay, recheck your answer. Okay, yes, okay, it's a V. Okay, the real part is positive, the imaginary part is positive. Therefore, the result is still in this quadrant. Okay, and it can help you to get in the adding point of view. Okay, the next one, how to help you for the multiplications point of view. If we have B and we have Y, okay, Y is the reward of the impedance. Okay, it's called admittance. Okay, if V multiply with Y or V divided by Z, give you I, the current from the Ohm's law. Okay, if V equal to 10, 55 degrees is here, the same. Okay, multiply with, okay, with the impedance equal to 1 plus 1j, or in the Phasor point of view, it equal to square root 2 at the 45 degree. You can see that you multiply between two vectors. What happened? The magnitude, you multiply them, right? 10 multiplied with square root 2. Square root 2 is about 1.4. It means the result equal to 14. Okay, and the phase angle will be, okay, at between 53 degree and 45 degree, it reached to be 98 degree, approximately that. Okay, you shift from here with another 45 degree, okay, and the magnitudes, you amplify them by 1.4, right? 1.4 give you here I equal to Vy, okay, equal to 1.4 or 14 at the 98 degree, approximately that. You can see that. How to use the Phasor diagram to addition or the subtraction and multiplication point of view. Now, in the real case, what about the Phasor form really? The RLC circuit shown in these figures, okay, at the figures 10, okay, at the 10.9, 39A, have several different voltage associated with VS, VR, VL, and the VC. Okay, you can see that in this case, VL is a voltage across the inductor, VR is a voltage across the resistor, VC is a voltage across the capacitor, and the VS abbreviated from the voltage source. The Phasor diagram is constructed by employing the single current as the reference. You must set one of these values to be different. The reference should be some common value, common quantity. In this case, all circuits will be connected in the series. Therefore, the common parameter is the current flow into them equal all. Okay. Therefore, if we set I, for example, in this case, if the current flow equal to 5 amp, okay, we set them to be 5 amp 0 degree first. Okay. Okay. You know that? Yes. Okay. For the voltage across R, due to the R is the resistance is only the real number. The voltage across R is have no angle. Okay. Set R is equal to 10, 0 degree. Therefore, VR will be the same direction, the same angle of the current flow to them. Okay. VR equal to, maybe in this case, 5 multiplied 10 give you 50 ohm. Okay. Give you 50 ohm. But for VL is not VL equal to, okay, 5 multiplied with the 50s is here, is even though the magnitude is maybe longer than VR, but the direction of them multiplied with J is the 90%. Now the quality result, the voltage across the inductor is the imaginary number. Okay, is here. And for the voltage across C is the same. Omega, okay, VC equal to I RC. RC or ZC. ZC equal to 1 divided by J omega C in here. This voltage. A minute. Okay. Now, if you would like to find the voltage across VL and the VR, okay, VL and the VR is here. Okay, you know VR, you know VL. If you know would like to find the voltage across R and L, both of them, okay, is here. And the adding them give you the 0, 1, okay, right eye shading. Okay. For VR and the VC voltage across here, okay, give you the orange one, okay, this voltage is here, all right. And if you add all, you can see that the effect of R and the effect of C, if you summing them, okay, okay, L equal to plus 50J, C equal to minus 50J. If you summing them, the total equivalent impedance equal to 10, because the effect of L and the effect of C will be cancel each other. Therefore, VS in this case, okay, VS in this case is the sum of all still equal to VR. Okay, equal to VR. Okay, this for example. Okay, another one example is for a little bit more simple circuit is RC circuit. And this RC circuit, if the questions give it to you, okay, omega equal to 2000. Okay, omega equal to 2000 radian per second. You can determine ZC. ZC equal to 1 divided by J omega C. It equal to minus 10J. Okay, R equal to 5 ohms. Okay, and the V will be here. The way to plotting them, okay, you can define in this term, in this circuit, the common term is the voltage across all. V, okay, the voltage of the current source equal to the voltage of 5 ohm equal to the voltage of this capacitor. Okay, we set the voltage at the angle to be 1 volt at the 0 degree. Okay, okay, you know V, you can find the current flow in the resistance. V equal to IR. I equal to V divided by R or divided by Z. 10 degree divided by pure real number of the resistance divided by 5. Therefore, in this case, IR equal to 0.20 degree. Okay, 0.22. But for IC equal to V that you get in here, Vs divided by minus 10J. Minus 10J. IC equal to Vs divided by here, 10 degree divided by minus 10J. Okay, IC equal to here. Now IC is here, IR is here. You can see that the current here. Therefore, the source current equal to IR sum with IC, right? IR sum with IC. You can use the Phasor diagram to adding them, and you can get IS in this case. Okay, write this line. Okay, IS in this case. Okay, if you have a chance to take the circuit lab, okay, the Phasor is play a very important role in the AC circuit analysis, okay, and the instructor will be show you the case too. Now for the last case, okay, for the circuit shown in these figures, okay, construct the Phasor diagram show IR, IL, and the IC. The same circuit, but in this case, the one we have for load, okay, connects to this current source, okay, determines the angle by which IS reading IR, IL, and the IC and IX. Okay. Okay. In we set the reference, okay, parameter first. If we assume that the voltage across all between the node, the top node and the bottom node equal to 10 degree, you see, okay, we plot the other value in the term of V. Okay, in the term of V. IR, okay, the current of the resistance already identical to the voltage across them directly. Therefore, IR equal to Vs divided by ZR, or Vs multiplied with YR. Okay, give you here 0.2 multiplied with 10 degree, give you here. Okay, you can see that the phase angle is already make the sense that the current and the voltage of this circuit will be the same direction. Next one, IL. IL equal to VL divided by VS, so multiplied by VS. IL equal to, yeah, you know IL, you know the voltage across them, okay? You can find IL here, okay? V equal IL equal to V divided by Z, or V multiplied with Y, okay? Multiply with Y. In this case, you can see that all unit already present in the Siemens S. Okay, after that you get IC. IC is the current flow in the capacitor. You know V, you divide by 0.5J. Okay, or sorry, you multiply by 0.5J because this case is the admittance case. Okay, after you get IR, IC, and IL, okay, you can see the direction of them. Okay, now you can determine, for example, if you would like to determine IX. IX is the result from IL plus IR. IL is here, IR is here. Therefore, IR equal to 0.20 degree, IL equal to 0.1 minus 90 degree, IC equal to 0.3, 90 degree. Okay, you can determine IR, IX first. Okay, IX equal to IR plus IL. Okay, adding them. Okay, it's already, okay, I don't show you the step to compute them. Okay, you know that if it's in the polar form, you must convert them into the rectangle form first, and you will be adding them or subtract them after that. Next one, IS. IS equal to IX plus with IC. Okay, IS for in here equal to IX plus with IC. You know IX, okay, you know IC. The sum of them will be here. Okay, you can calculate the result by plotting, okay, the Phasor analysis here again. Okay, shift there, from here. You connect between one vectors, okay, another vectors, okay. You can use, okay, the heads link with the tail of them, okay, connect them and plot them. IS equal to IR plus IL plus IC for this case. And for the summary, in this case, you can see that IS, okay, reading IR by about the 45 degree, okay, 45 degree, and IS, okay, IS is here. IS is readings IL by 135 degree. 100. This, okay. For IL is only 90 degree in this point. If you want to move to this IS vector, it require 135 degree. Okay. And the last one for IC, IS is reading ICs is only by minus 45 degree instead. Okay, IS and IX relationships is here, 71. Okay. Now it's your turn. Now, can you listen up? I think some of you already a little bit sleepy. Now it's your turn to wake up. Can you see my slide?
Yes, sir.
Okay,
Yes.
capture it. I will stop sharing in 5 seconds. 4, 3, 2, 1. Using the nodal analysis, okay? Analyze that. And the unit already in the cement. Be careful about that step. Okay, I think it's a suitable time to checking your attendance, okay? Except one of your friends that I remember the face, okay? Turn on the camera now. Jim, hello?
Hello, sir.
Are you a cat? I see your
No.
symbol. Are you have a cat? How many cats you have?
I have dog.
No. Your symbol is the dog, but you use the cat. Sorry, your symbol is the cat, but you have a dog.
I like both pet, but like my family allow me to pet only dog. That's why.
Okay. You love different from your friend. I think more of your friend maybe would like to have the girl instead. Or not? Okay. Hello, Java. Are you okay?
Yes, Ajahn. How are you?
Fine. Yeah. You have all of you have maybe only 2 or 3 weeks, right? About 3 weeks for final. Okay. Okay. Fukan and Lacha is okay. Told me that the camera is not work. Okay. Why? Try to fix them because if it not work in the final, I cannot grading your mark. Clear? Because at least I must have. I can check the evidence. Are you okay or not? Okay, now let's do it. Okay, during this time, I will checking your attendance. I give you 20 minutes, okay, to finish the nodal analysis and try to compute them, okay, and show me about the result. Okay, I go to drink a little bit, okay, 1 minute, and then we come back. Okay, I'm still back. I'm come back. If you have any question, you can ask me. If you already can find the final solution, you can post, okay, write them in the meeting chat, and I can check it for you. 22 minutes after this, I will provide you complete solution for this question, okay? I will come back in 2 minutes, okay? Okay. Can you hear me? Hello? Anyone can hear me?
Yes.
Okay,
Yes,
can
sir.
you see my slide?
Yes. Yes, sir.
Okay, we don't have much time, okay? Therefore, if you're not finished yet, okay, you will see them roughly and try to solve by your hand soon, okay? And see that you maybe see the detail by in the slide later, depend on you, okay? Now I will provide you the complete solution and in detail for this example, okay? Using the nodal analysis on the circuit of the following figures to determine the V1 and V2 in both the Phasor form, okay? Here V1 is in the left hand, V2 is in the right hand. This circuit is contain only 3 nodes, but one of them is already the reference, right? The bottom one is already in the cloud, therefore it will be the reference node. The unit in this case is already right in the cement, okay? Is in the Y, okay? In the cloud, okay, the node 3, you set them to be the reference. Node 1, you set to be V1, V2, and yeah. Now, we can establish, okay, at the node 1, you can establish the KCL at this node. For the KCL, Kirchhoff current law at this node, how many checking first? How many branch connect to this node? 1, 2, 3, and 4. 4 branch connects to this node, okay? And in this case, it have only one current get in, 20 degree. 20 degree. 3 current get out, okay? In here. We apply the KCL to the node 1, okay? 1 current get in. Okay, 1 current get in equal to 20 degree. Okay, unit of them is milli. You can see that milli in here. Okay, 3 current get out. 1 is here. 50 minus 90 degree. 50 milli minus 90 degree. Okay, from here, V1 minus 0. In fact, it must divide, right? But in this case, it's already in the cement. Therefore, V1 multiply with Y. Okay, V1 divided by Z or equal to the V1 multiply with Y. V1 multiply with 50J. 50J V1. Here, minus 25J milli. Okay, yeah. V1 minus V2. V1 minus V2. Reorganize the equation, okay? Try to group them, okay? Set them to be the constant coefficient of the V1 and constant V2 and the constant in here, okay? For V2 is here. Okay, for V2, okay, we have 3 band connect to them. 3 band, 1, 2, and 3. Okay, 1, 2, and 3. Okay, For the 3 band connect to them, okay? Current, how many current get in? It have only 1 current get in. 50 minus 90 degree, 50 minus 90 degree, okay? Current get in equal to current get out. 2 current get out into branch, okay? For this, V2 multiply with 40 milli. V2 multiply with 40 milli. And for this branch, okay, for this branch, V2, minus 25 milli multiply with V2 minus V1 minus 25 J milli to V2 minus V1. The rest, you can see that after you can model this equation, the rest is based on the polar form and the complex number computation. That is very unlucky that you cannot use your simple calculator to solve them, because your simple calculator can solve only in the real number manner, not the complex one, okay? After you organize them into this form, the first equation and the second equation is already in the suitable form. You push them into the matrix, okay? These equations can be written in the metric form as here, okay? And these equations are easily to solve in the most scientific calculators, okay? You can use the karma rule and determinant to solve them. I don't show you the way to solve them again. It's already present in the lecture part, but this is already present in about the solution of the exercise, okay? Now you get V1 equal to 0.98 plus 0.42J, okay? V2 equal to 1.02 minus with 1.22J, okay? The time domain solution are obtained by expressing V1 and the V2 in the polar form. Into the polar form, yeah? Okay, 0.94x plus with the 0.42J is here. Therefore, it equal to 1.623 degree, 23 degree. After you convert from the complex number into the polar form, you can convert the polar form to the time domain easily. The magnitude is 1.06 is here. Okay, the phase angle shifting is 23 degree. 23 degree. 23 degree is here. Omega and T is here. In this case, you don't know what about the omega is. Therefore, we hold the omega as the unknown first. For V2 is the same, 1.02 minus 1.2J. Convert them into the polar form, provide you 1.95 at the minus 90 degree. After you get the polar form, it's easily to convert them into the time domain form. Okay, the time domain form is the magnitude is 1.95 cos omega t with this phasing shifting angle minus 90 degree. Okay. Now another one is provide you as the exercise. Okay, and I will give you the solution in the next time. Okay, yeah. Can you see the slide? Capture it. Okay. You will, if you do by yourself, I think is and the next time I will provide your solution. It's good for you because you can solve them by your hand and you will know that the thing that you do is right or wrong. Yeah. Finish? Hello? Anyone can hear me?
Mm-hmm.
Already captured the question?
Yeah. Yes.
Yeah. Finish? I stop sharing in 5, 4, 3, 2, 1. Okay. Okay. Any question for this lecture?
No, Ajahn, thank you.
Okay. See you next time. Okay. I give you only one exercise. Okay. And I hope that only one. I think you can have the time to do that. Okay. If you have the responsibility for your job. Okay. See you next time. Good luck. Okay.
Thank you, Ajahn.
You're
Thank you.
welcome.
Thank you, Ajahn.
You're welcome.